Every QA team I know has the exact same bottleneck. User stories arrive on Monday, test cases aren't ready until Wednesday. That's 2 days of delay every single sprint, just waiting for test coverage to catch up with development. I fixed that with a 94-line Python script, not a massive platform, not a $500 a month SaaS tool. 94 lines of Python built on LangChain, and it now generates test case skeletons in 8 seconds. Today I'm going to show you the exact architecture, walk you through the code line by line, and where it breaks. The first question you're probably asking is why LangChain? A raw API call to Claude or GPT-4o works, but here's the problem: structure. Without a controlled output format, you get prose, bullets, or an apology. LangChain solves this with output parsers. You define a Pydantic model, and the framework enforces that shape. If the model drifts, the parser raises a clean exception. That's why LangChain is worth the overhead here. Before we look at code, let me give you the mental model, because this architecture is clean and reusable. The generator is 3 components chained together. Component 1, a prompt template where your heuristics live. Component 2 is a model-agnostic LLM call. Component 3 is a structured output parser backed by Pydantic. These 3 are wired together using LangChain's pipe operator, the vertical bar concept from Unix pipes. Now let's look at exactly how each piece is built. Let's start at the top with the imports. Nothing exotic here. We have our LangChain wrappers and Pydantic for the data modeling and parsing. Now the Pydantic model, this is the schema that defines what a test case looks like: title, steps, and expected results. The field descriptions are important. They tell the model exactly what to populate in each field. Next, we instantiate the parser in one line. This parser knows the shape of a test case and enforces it. Now the prompt template. We have 2 variables: format instructions and user story. Format instructions are auto-generated. It tells the model exactly what JSON structure to return. You never write this manually. Now we instantiate the model. Temperature at 0.3 is deliberate. We want consistency, not creativity here. Now we wire everything together. That's it. Prompt flows to LLM, then to the parser. One line. Finally, the function wrapper. The try-except handles parser failures gracefully so your pipeline doesn't crash. Let me show you what comes out the other end. I feed in a standard password reset user story. The happy path is easy, but the edge cases, like expired links or double clicks, are where this earns its place. In our comparison, manual authoring took 18 minutes. The generator took 8 seconds plus a 4-minute human review. In my setup, an N8N webhook fires when a Jira story moves to in progress. It's fully automated. If you're running flaky test investigations, dflaky sits downstream to catch unstable tests once they hit CI. The 94-line claim is for the module only. The full system is closer to 400 lines and human review is mandatory. Remember, it produces skeletons. A human still writes the actual playwright or Selenium code. Be precise about which parts stay human. Judgment and risk are human. Boilerplate and formatting are for AI. Full code is linked below. See you in the next one at Automate and Elevate on YouTube.